Everybody talks about radiation. It's in the news, in movies, in comic books, and for a lot of us, it's even in our day-to-day lives. But what is radiation? And what's the difference between good radiation, like chemotherapy, and bad radiation, like a nuclear weapon? Well, when an atom is really unstable, it will release a particle, like a neutron, some energy, or both. And it will do this in an attempt to stabilize itself. The high-energy material is what we call radiation. The high-energy radiation, like energy in the form of light, is much more dangerous than low-energy radiation, like a helium nucleus that's given off. The dangerous energy that's released as radiation, a lot of times it's in the form of an X-ray or a gamma ray. And this is why if you get an X-ray at the hospital, they'll give you a lead apron to help protect you from the excess radiation. Radiation comes from two types of reactions: fission reaction and fusion reaction. Fission is what happens to uranium and plutonium and what they use in a nuclear power plant. Fission is what happens when an unstable atom falls apart in order to stabilize itself, and it releases some radiation. Fission can be helped along by achieving what's called critical mass, which just means that you take a lot of radioactive material and pack it together. Having all this radioactive material in a small space actually causes the fission of one atom to cause the fission of another atom, and it causes the entire mass to fission almost instantaneously. The other reaction is fusion. Fusion is when you take two atoms and you smash them together at very high speeds and high energies, and it forms a new element. For instance, when you take two hydrogen atoms and you smash them together, you get a helium atom. This is actually what's going on in our sun and why it's a good idea to wear sunscreen. What's left behind after radioactive decay is sometimes a stable element, but oftentimes it's another radioactive element, and these elements will continue breaking down until they reach a stable point. The amount of time it takes for half of a sample to radioactively decay is called the half-life, and the half-life is dependent on the stability or instability of the sample. For instance, the half-life of uranium-235, or fissionable uranium, is about 700 million years. Concentrating it into critical mass, like for a nuclear reactor or a weapon, severely increases the rate of fission. The difference between good and bad radiation is quantity and control. So a very small quantity of radiation over a short amount of time is just fine for you. But a large amount of radiation or a long exposure to a lot of radiation is what causes health problems. A great example of this is a nuclear reactor. When a nuclear reactor is functioning properly, it's controlled and it's isolated, and it's what we would consider good radiation. However, when the fission gets out of hand, it's called a meltdown.
Mr. Burns, people are calling this a meltdown.
Oh, meltdown. It's one of those annoying buzzwords. We prefer to call it an unrequested fission surplus.
So radiation in small doses is relatively harmless, but radiation in large doses or over a long period of time can be harmful or even fatal. Most of us never even know when we're exposed to a small amount of radiation, but if you ever are exposed to a large amount of radiation, you need to make sure you take the proper precautions. Luckily, most of us will never have to worry about exposure to a large amount of radiation, but wear sunscreen.